Hello everyone, welcome to this section of the tutorial where we talk about deep learning models, and I will start with generative adversarial neural network. All right, so what is a GAN? GAN, I want you to of it as think of two items. Okay, so from the word itself, generative adversarial network. So I want you to think of two items: generator and discriminator, which are adverse at each other. So the generator creates like fake data, in our case, fake images, which will resemble real data. Then a discriminator tries to distinguish between real and fake data. So the goal here of the generator is to fool the discriminator into thinking its output is real, while the discriminator improves by becoming better at identifying fake data. Uh, Think of it as a minimization and maximization game. Generator minimizes the probability of the discriminator to identify fake data as fake, while the discriminator maximizes its ability to differentiate real from fake. So what I'm going to do, I'm going to give you a quick walkthrough, and we're going to go straight into our Jupyter notebook and code along. Now, I thought I was recording it when I did earlier, so I'm going to start a little bit into the code here. But what you're going to do, we are going to use the MNIST dataset of 100 digits. We are going to generate data. We are going to generate realistic images of digits as we have in the dataset. That's basically what you're doing here. So the goal here is we are going to, of course, import our libraries. Then we're going to load the dataset. Then we're going to build our generator. We are going to build our discriminators. Then we do optimizers, parameters, and also do our, of course, our training, and of course our printing out of the images that we want. So it's going to be a code along, and go ahead and import the libraries. I've got NumPy, Matplotlib, TensorFlow. From TensorFlow Keras, we have layers models, and of course the MNIST dataset. Then we load the data, go ahead and load the data. And again, before I get started, I will save this code into my GitHub repository. So if you want to access this file, go to my GitHub. I'll provide the link into the in the description, and go to my GitHub, download the code, and plan and maybe to start from there, or you can just follow along as I code. Anyway, let's go ahead and go on. What I want here is do the WASA, we call it the WASA stain loss. I don't know if that's the best way to pronounce it. So I'll be checking to see if my recorder is working here. Otherwise, I don't want to start one more time again. All right, and I'll be faster since I thought I was almost done with this thing. Now I know when you gonna do, we want to multiply these two. So I'm gonna copy. Like I said, I'll be a little bit faster on this one. Now I need another function that calculates the gradient penalty. So what I'll do is I'll do gradient penalty later and bit size. So what we're gonna do here is to do alpha, then random. Now it takes time for you to know all the methods if you are just starting out, but the more you code along, the more you are exposed, and the more you recall and to be able to apply. So I always encourage people, code along, and with time, um, you will be able to, it will be second nature to you. So my TensorFlow, I want to cast. Just make sure it's a correct data type here. So this will be fake images. So now we do things differently, but I've discovered that if I go ahead and write what I have in my mind, then come back and look for the errors, maybe typos, it's better than to always stop myself, fix every error as I go. We are all different, and do what works for you. Sometimes I just code and then come back up at the end to say, oh, what was I doing here, and correct as I go. So what I'm going to do is to width gradient tab. I want it as a tab. Then we want our bread. Actually, yeah. Okay, okay. All right. I'll use the square root. Which is some here, and square grads here, and let's specify the axis. So one more time. Okay. So my penalty is goes to reduce mean of the norm 1.0. I want it to be this, and return penalty. Let me look at it one more time. Okay, let's move on. So now what we need to do is to do two things: build the generator and the discriminator. So I will just say generator, then we're gonna build discriminator. So on building the generator, what we need is another function, which I just call build generator. So models, So what we need here is layers dot dense. We want to specify our layers. So ours will be 7, 7, and 128. Then our input will be 100. And also, I want layers reshape. So for layers reshape, we'll keep again as above 7, 7, and 128. So here, want 2D transpose. All we need is to 128. Our kernel size, I'll push it on 4. My strides, I'll push them on 2. Padding, I'll just keep them on the same. Okay, layers. I want to normalize the pitch here. I'll go with 0.8 and yes. So let me go do actually it's really cute. All right. And if I'm too slow for you, go ahead and speed up the speed, the playback speed, because right now I'm typing and thinking at the same time. And it might come out as super slow for some. I'm trying to copy here again and do the last one, layers. Actually, I don't need transpose here. I would need 1 point, the kernel size. I know I'm using a, you can use double quotes here if you want to. It's all, here is all about choice. But to be consistent, let me just use double quotes everywhere. Activation, kernel size, and V2D. So what I want to do here is to return model here. Then I want to do almost the same for the discriminator. So, so for the discriminator, what I need to do is another function. So that function, I'll call it build discriminator. Need to, so for build discriminator, I'll need my model is equals to models dot again sequential. And I'll use this. Oh my goodness. All right. So I'll do layers.con. Mhm. Then layers. I may go a little bit faster because I intend to hit 30 minutes per each and every, less than 30 minutes per each and every model example. All right, so we're gonna do again layers dot. Mhm, 0.25 layers dot flatten, and lastly I want to do layers then one. Mhm. Then I'll now return this model. Perfecto. All right. Gen and discriminator. So to do this, just do generator is equals to our build generator function, and discriminator is equals to build discriminator function. Discriminator, and discriminator is equals to build discriminator. All right. So go ahead and do optimization. So we're gonna do a miser is equals to, I need an optimize a G. Okay, D miser. So what I need here is to use the Adam, and I want it to be 0.5. So for beta 2, I want it to be 0.9. And actually, I can do the same for. Then let's go ahead and train parameters. So I'll not go 10,000 precise. 64. my sample interval is equals to 1000. This is just the gradient penalty coefficient. So here's the training loop. So in my earlier video, I kind of gave an outline on on the flow of how I solve the problems. So I think on my next, I will also share the same flow here. So on here, I want fake images, and I'll also want the page size. This is a function. Actually, I need real images. I need real images here. And page size, dot shape, and you still use real images. All right. Noise is equals to I would want page size again. Then yeah, fake images. Then noise training is equals to true. Then I would do tap. Real prediction. Okay. Discriminator. I want real images training. That's just the true. Then fake pred. I want discriminator. Then fake images. 22. Then make a gradient. I'm trying to go as fast as I can to save my time here. Alrighty. Then I'll do another variable delos. Then I'll use the reduce mean and do fake bread minus real bread plus my lambda GP. I set it on 10, so I want to multiply with the GP here. All right. Then what I need to do, what I would do, okay, let me just finish this one. Gradient, so my delos discriminator enable variables. Then I want to do my de-optimizer dot apply. Then I want discriminator trainable, and I'll wrap everything in zip, so it will be a zip. Then let's go ahead and train the generator. So to train a generator, um, okay, we want the page size. We are kind of doing the same here. And let me see if I can copy this one and change a little bit. Then all I need is to return dlos and glos. Let's go ahead and save generated images. To save a generated image, let's create a function. So what I'll do is def generated images. All right. So I need 0, I need 1. Then here I need, actually it's to the power. And I multiply it by gen images. Then I want to just add 0.5 here so that I can kind of rescale it. All right. Let me do fig. I'm using a for loop here. J in range, and again I and J here. One gen images underscore imgs. Then I want to wrap it up and say I n plus J, everything, then comma. Okay, CMap. All right. AX. Again, I will do it this way. My I and J. I can turn it off here. And get out of the for loop and on the initial for loop. I'll do generated images. I'm gonna show this one. And now what I do is I wanna train what I would do is come here, train my GAN. To train the GAN, what I need is to create a function that get the random batch of real images, then train the GAN, and then just print the progress. So create a function that get random batch of images, train the GAN and print. And lastly, what I need to do is to start training. And to train, I'll just run everything, then extrain. So this is my code. I'll just do a quick one to see if there's anything that I missed. And there should be some of the things that I've missed, but I'm just gonna, sometimes it's always good to run. Okay. All right. And let's see. Okay. Yeah. All right. What I'm going to do is to look at all these and correct the, of course, some commas that I missed. Then what I'll do is I will pause the video, look at the errors, and come back and see share the results. Running, and let's see how this is running. It's going to take a minute. So if it takes longer than what I anticipated, I am going to pause it one more time. And okay, let's see. Okay, I'm generating images, but they are not that what you call it, visible to the human eye. So I might need to fine tune my model to make sure that these images are a better, are easier to see. Um, But basically, as far as the concept of using generative adversarial networks, this is basically how you do it. You create a generator and a discriminator. They fight against each other. This one will be creating images. This one will be counteracting this one. And over time, as you train with more data, it will be able to perfect the images. So I'm going to look at it and see if I can advance to it. And for now, I would say thank you. See you on the other side.